Hey folks, so this unit is about radicals. And so what we need to do is build a little bit of background information. Today we're going to add, subtract, multiply, divide, simplify radical expressions, and then relate exponents and radicals together. All right, so let's get started on this for today. Okay, so before we get moving into the product property, I want to mention a little bit of some vocabulary that I will be using today. So suppose I have just this right here. Let's say this is x plus 1. Okay, we need to know what different parts of this are called. The x plus 1, that is called our radicand. The root symbol, that's our radical. And then the 4, okay, that's our index. That's what root we're taking. So I'm going to be using these terms today. So we need to know what part of the expression I'm referring to. So let's review the product property for our radicals first. The product property says that if I have the nth root of a times b, I can split it up into the nth root of a times the nth root of b. Likewise, if I have indexes that match, I have a 3 and a 3, so they're both the third root, I can combine the two radicands together under one radical. So I could rewrite this as the third root of 16 times 4. Well, how does that help us simplify things? Well, the third root of 16 times 4 is the same as the third root of 64. And do I know what that is? Well, the third root says I need to, what multiplies by itself 3 times to get to 64. Now, when I want to simplify radicals, what I do is I write my radicals as products of primes. So I simplify it all the way I can. So I would make a tree. If I can't break this down in my head, I would make a tree, and I know that 64, well, we just did 16 times 4. I know I can divide it by 4, and I get 16. And I can divide this by 4, I get 4 and 4. And this is 2 and 2 and 2 and 2 and 2 and 2. So I know this is 1, 2, 3, 4, 5, 6. I know that this is the third root of 2 to the 6th power. And so just like square roots, I need groupings to be able to bring them out. So the way I do this, I need to think, how many times does 3 go into 6? Well, it goes into it twice, so I have two groups of 2 to the 3rd power. So that means I can bring out 2 2's. So 2 to the 4th, or 2 squared, so that is 4. Okay, so that's how you would simplify this. 3 goes into 6 twice, okay, so I can bring out a 2 squared, which is just 4. And we'll practice some of these a little bit later. Now I have the quotient property. Quotient property says that if I have the nth root of a fraction, okay, I can break it up and I can take the nth root of the numerator over the nth root of the denominator, as long as b is not 0, because then you'd be dividing by 0. So this works for us sometimes when we're dividing two roots and the indexes match up. So here I have the 4th root of 80 over the 4th root of 5. And if I do this, okay, this is going to be the 4th root of 80 over 5. So basically I'm going backwards from this property again. So this is going to be the 4th root of 16. If I break 16 down, I know that this is the 4th root of 2 to the 4th. And 4 goes into 4 once, so I can bring out a 2 to the 1. And there's nothing left, so this is just 2. Now let's take a look on the other hand at this problem right here. This is the 3rd root of 10 divided by the 3rd root of 3. Well, if I bring these together, I would have that, the 3rd root of 10 over 3, and that doesn't really help me out that much, so I need to figure something else out. And so what we're going to do, if I have something like this, and I can't combine them under the same root and make it simplify, is I need to rationalize the denominator. And how do I rationalize the denominator? Well, if I were doing square roots, you would just multiply whatever by another root of the denominator. Well, this is the third root, okay? And I need to think, well, how do I undo a third root? Well, I need 3 copies of 3. I need a 3 to the third in here, but I don't have a 3 to the third. I only have a 3 to the first power, so I'm missing a 3 squared, the third root of 3 squared in there, so that's what I need to do. So I have the third root of 10 over the third root of 3. And what am I missing to make the denominator nice is I'm missing a third root of 3 squared. And how does that help us out? Well, if I use the product property on the bottom and I combine the denominators, this is going to be the third root of 3. Well, I have 3 to the first and 3 squared, that's 3 to the third. And then on top I have the third root of, if I combine these two, I have 10, and then 3 squared is 9. So 10 and 9 is 90 when I multiply them together. So now let's look at our denominator. Well, since I have the third root of 3, 3 goes into 3 once, so this is just 3 on the bottom, because this third power and the root, those will undo each other. And so that is the simplified form for that problem right there. Now, adding and subtracting roots. Here's what we need to have. You need to have that the index and the radicand match. That's the only way you can add and subtract roots together, is if those two things match. So let's see if we have that. I have a third root. Radicands are both 24, so I can combine these two. If I have 1 third root of 24 and 6 third roots of 24, that means together I have 7 third roots of 24. Okay. But we can simplify that even further. If I break down 24 into its products of primes, I could rewrite 24 as 2 cubed times 3. Well, why can I do that? Well, 2 cubed is 8, and 8 times 3 is 24. If you need help on this, just make a factor tree and then count up how many copies you have of each prime. So now let's simplify this a little bit. Well, 3 goes into 3 once, so that means I can, since I have a 2 to the third, I can bring out a 2 from this. So I have 7, and then I can bring out a copy of 2, and then nothing's left over. But this is a 3 to the 1, and so I don't have 3 of them, so that has to stay underneath the radical. And so I have this. Simplify, 7 times 2 is 14, third root of 3. Let's look at this second example. Here my radicands match, but my indexes, that's a 3 and that's a 4, so I can't do anything with this. Since my indexes do not match, nothing I can do with this. They must match to add and subtract roots. To multiply roots together, the only thing that needs to match is the index. Okay, so these are both square roots. When there's no index, then it's a 2. Okay, so these are both square roots. So to do these, I just need to multiply the 3 and the 2, so that's a -6. And then I use the product property to combine these two. It's the square root of 12 times 18. So this is -6, and then the square root of 216. If I break down 216 using a factor tree, I get that this is -6, and then it is the square root of 2 cubed and then 3 cubed. Let me put the factor tree up for you. So here's the factor tree of 216. So you can see that it's 2 cubed and 3 cubed. So now we want to simplify this a little bit. So recall that my index is 2. So I want to simplify this. So 2 goes into 3 one time, so I can bring out a 2, but then there's 1, 2 left over, because there's 2 goes into 3 once with 1 left over. So there's 1, 2 left in the radical. And then 2 goes into this 3 right here once, so I can bring out a copy of 3, but then 1 is also left over inside the radical. So now I want to multiply all these together. I get negative 36 root 6. So that is that simplified form. Next up, I have two binomials I want to multiply together. Okay, so we just need to double distribute. So root 2 times root 2 is just going to be 2. Root 2 times 4 is a plus 4 root 2. Negative 1 times root 2 is a minus 1 root 2. And negative 1 times 4 is a minus 4. Now I just combine my radicals and my integers. Well, 2 and negative 4 is negative 2. 4 root 2 minus 1 root 2 is 3 root 2. So that is the simplified form for that one. Okay. So let's consider this for a second. The square root is with an index of 2, okay? And I could also write that as x to the 1/2 power. You may have seen that before, you may have not. Well, let's see why that is. If I have something squared, then I take the square root, okay? We usually say that they undo each other and I will get x. Okay, well, why is that? Well, let's take a look. If I rewrite the radical, okay, as to the 1/2 power, if I rewrite this as x squared, and then instead of writing the radical, I write it to the 1/2 power, you can see powers of exponents, when I have a power to a power, I multiply, and 2 times a half is just 1, so this is 2 to the, or x to the 1, which is just x, and so that's why they undo each other. So what's the third root of x? What would that be? Well, that would just be x to the 1/3 power. And let's see why that is. If I have x cubed and I take the cube root, let's rewrite it using a rational exponent. X cubed, and we're saying that the third root is to the 1/3. 3 times 1/3 is 1, so that's just x. Okay, so they do undo each other. So now let's consider that we have a to the m over n. So we have a to a fraction, basically. So we could rewrite this, okay, by separating this out as a to the 1 over n to the m, reversing the power to a power, or we could rewrite this as the nth root of a to the mth power. And so what you really need to take out of this little bit right here is if I have a to the m over n, keep this idea in mind. The denominator, that's your root. The numerator, that's your power. If you keep these two ideas in mind, then you shouldn't have a problem manipulating our expressions. So the numerator is your power, the denominator is your root. So let's think about this. So this is 16 to the 3/4. How could we rewrite this and try to simplify this? Well, I know since the 4 is in the denominator, I know this is the 4th root of 16. And since the 3 is in the numerator, I know that that is the power. So it's 4 to the 4th root of 16 to the 3rd degree. Okay, so can I do this? Do I know what the 4th root of 16? Well, the 4th root of 16 I know is 2. Okay, so this is the same thing as 2 cubed, which is 8. Okay. So let me also make a side note on here that we could have written this a different way. We could have written this, I'll write it over here on the left, we could have written this as 16 to the third and then taken the fourth root. It doesn't matter what order you uh, perform the operations. If I had done the third power and then the fourth root, well, I can't do this in my head, okay? 16 cubed and then the fourth root of that, I can't do that in my head. So it's often easier to take the root first and then do the power. So if I were to give you something without a calculator, keep that in mind. Take the root first and then do the power because you're dealing with smaller numbers. Okay, so now let's rewrite this one. Okay, since that's my power, so I know that's in the numerator. Okay, and that's the denominator because that is my root. So I could rewrite this as 8, okay, to the 5/4. Again, your root is your denominator and the power is your numerator. And there is no, the fourth root of 8 isn't a nice number, so we can't really simplify that any further. Okay. So now I want to simplify 256, the sixth root of 256. Well, you can do a factor tree with 256. On the side there, I'll give you a second. Okay, you got it? All right, so if you've done that, you would see that this is the sixth root of 2 to the 8th power. So how do I go about simplifying this? Okay, well, 6 goes into 8 one time, so I can bring out a 2 to the first power. And then I have the sixth root of, well, how many are left over? If 6 goes into it once, there are 2 left over, so it's 2 squared. Okay, so this is 2, and then the sixth root of 2 squared. Well, can I simplify this at all any further? Some people might be satisfied leaving it like this, but using what we just learned, I could rewrite this right here. I could rewrite 6 2 squared. I could rewrite this as 2 to the 2/6. Okay, this is my power, that is my root. Well, 2/6, I know that reduces to 2 to the 1/3, so I could rewrite this part as 2, and then this is my root, so it's the third root of 2. So I could simplify the whole thing down to this. Okay. All right, now simplifying expressions with variables. Okay, so when we have this, when we're trying to simplify expressions with variables, we usually have some coefficients in here. Okay, and you always want to break those down into products of primes. Okay, so if I do this and I break this down, I have third root. 64 is 2 to the 6th power, and then I have y to the 6th. And then you just go through the process. 3 goes into 6 twice, so I can bring out a 2 squared. And since it goes into it evenly, there's nothing left over in the 2's under the radical. And then 3 goes into 6 twice, so I can bring out a y squared, and there's nothing left over, so that is my simplified form. I could rewrite it as 4y squared if I chose. If I break down 24, I have third root. This is 2 cubed times 3. 8 times 3 is 24. M to the 6th, N to the 4th, R to the 7th. Now let's just walk through each little piece. 3 goes into 3 one time, so I can bring out a 2 to the 1 with nothing left over. 3 does not go into, well, what's the power here? The power is 1. 3 does not go into 1, so the 3 must stay underneath the radical. 3 goes into 6 twice, so I can bring out a m squared with nothing left over. 3 goes into 4 one time, I can bring out an n to the 1, and then there's 1 left over. 3 goes into 7 twice, and then there's 1 left over. So if I clean this up a little bit, I have 2 m squared r squared n, and then the third root of 3 nr. Last one, I want to break down 243. You can do a factor tree. I end up with the fourth root of 3 to the 5th power, a to the 15th, b to the 8th, c to the 9th. Okay. And then we just walk through looking at our exponents. 4 goes into 5 one time, so I can bring out a 3 to the 1, but then there's 1 left over inside. 4 goes into 15 3 times, so I can bring out an 8 to the 3rd, and then there's 3 left over. 4 goes into 8 twice, evenly, with nothing left over. And then 4 goes into 9 twice, with 1 left over. Simplifying this out a little bit, I have 3, a cubed, b squared, c squared, and then I have the 4th root of 3, a cubed, c. And that is the simplified form of that. Okay, mathletes, I will see you in class. Enjoy your break.